What's going on, guys? Stefan here from App Stuff. Hope you are doing well. In today's video, I'm going to be teaching you how to network like a pro. So we're going to be going over some awesome professional networking techniques like pagination, refreshability, error handling, asynchronous code, and we're going to be doing all that with SwiftUI and an amazing cryptocurrency app. So get excited for that, guys. Let's go ahead and get started. All right, guys, so to kick things off, make sure you go ahead and download the starter project for this tutorial. It is absolutely free. The link is in the description, and it just contains all the code that's required to produce this basic version of the application that we see here. And throughout this tutorial, we're going to implement additional features and functionality like error handling and pagination and refreshing. And we're also going to improve our networking code by using SwiftUI's awesome new feature of async await. So just make sure you guys go ahead and download that. If you want the full completed version of this course, guys, I do have a course on my YouTube channel for this. So if you guys want to check that out as well, here's what the completed version of this project looks like. The link will be in the description there as well. I also have a bunch of other awesome stuff like Uber clones and Twitter clones. So make sure you guys go ahead and check all of that stuff out on my YouTube channel. And on that same note, before we get started with the code, make sure you guys check out my website as well. It's stefancodes.com, where I have a bunch of awesome products and professional courses that you guys can have access to. If you guys want access to the YouTube stuff here that we're doing now and all of the source code associated with it, go ahead and hop over to the YouTube courses page that is under the courses guy. And you guys can also sign up and become a member to unlock additional features about all the products that I have, like discounts on source codes, courses, one-on-one coaching, and all that awesome stuff. And if you sign up and become a platinum member, you actually get one free course or source code absolutely free, which is $100 value just for signing up and paying 20 bucks a month. So make sure you guys go ahead and check that out as well. But without any further ado, guys, let's go ahead and get started by doing a quick run through of this starter project that we have. Let me get my code opened up back here again. So basically, guys, we're just fetching some data from an open API, and we're displaying that data in a list. So here's what our view model looks like. We have this coins object. We have some URL that we're fetching information from. We're using the CoinGecko API. You guys can go ahead and check them out if you want to. And then we just have this really simple fetch data function, right? So we're fetching it with the URL session. And this is what we're going to be modifying. We're going to be using async await as opposed to using this URL session, which is sort of the old school way of doing things, and it's a lot messier and not as performant. So we're going to be changing up the functionality there. But let me just go over the rest of the structure of the project. In our model folder, we have our coin, and it's pretty simple. Just has a couple properties. It's a very simple struct, and we're using these coding keys to decode all this data from the incoming stuff from the API. We have a sample coin here, so that our previews will still work. We have this coin error structure that we're going to be using a little bit later in the video when we handle all of our error. And then in the view, this is also pretty straightforward. We have a list, and we loop through all the coins in the view model, and we create this coin row view, which is what you see right here. Make this a little bigger for you guys. And this is what the coin row view looks like, right? We just populate it with a coin. And then the UI is pretty straightforward. We're also using async image here as opposed to Kingfisher. There are some downsides to async image that I'm going to touch on in another YouTube video, guys. So make sure you just go ahead and smash that like button and subscribe to the channel to stay tuned for additional awesome content that I'm going to be putting out for you. There is a problem with async image that no one is talking about that I'm going to go over how to fix. And get like a serious performance improvement out of it. So that's going to be coming in a future video. Make sure you guys stay tuned and click that subscribe button down below. So anyway, guys, let's go ahead and now get started with the code. So we are going to hop over to our view model, and we're going to go over how to eliminate the use of this URL session data task with all this nasty completion handler stuff. So you guys notice we have an extension for the URL session functionality. We're going to do the same thing for the async await functionality. So really quickly, let's just go ahead and inside of our content view model, just go ahead and create another mark for our async await code. And we're going to say extension content view model. And we are going to write a function called fetch coins async. Cool. So we are still going to need this URL here, guys. So that's the URL we're going to be fetching our data from. So we can literally just copy and paste this from our function that we have down here. So really quickly, just to do a quick breakdown of this URL, we're getting this data from coingecko.com, and this is the base URL. And then the rest of this crazy stuff you see here is all of the parameters that we need to pass up in order to get this specific set of data back. So not going to be doing a deep dive into the API. This video is more centered around how we are interacting with the API. But if you guys do want to check that out, just head over to api.coingecko.com. Awesome API, really, really cool service. But anyway, we have the URL. So now let's go ahead and go over how we're going to actually fetch data from that URL using async await. So we are still going to use URL session, guys, but we're going to use a different component. So we're going to say URL session.shared.data, and then you're going to say data from. And let's take a quick look at the documentation here. So you guys notice that this is an asynchronous function that throws an error, that can throw a potential error. It's throwable, right? So this is different than data task, and we'll look at the documentation there in a second, but essentially this allows us to use the async await functionality. So we're going to say data from URL. And something I forgot to mention that's extremely important here is this actually returns a data and response object, right? And because it throws an error, the error is implicitly handled. We don't need to actually look at the error there. So this is a tuple or tuple, still don't know how to say that to this day, but it's a tuple that is just going to give us back some data and a response. And this is way cleaner code because it doesn't require the use of a completion handler, which is awesome, right? So let's go ahead and see how we're going to store this information inside of a tuple. So we can just go ahead and say let parenthesis data response equal URL session.share.data from URL. So this is way, way cleaner than the code we have down here, guys. So this data task, if you hold down Option and click on that, you guys notice that this has a completion handler, and then everything has to be handled inside of this block. We have to use weak self here to avoid retain cycles and just a bunch of nasty, nasty stuff. And this is just a simple API call, right? You can imagine that as API calls get more complex and your backend is more complex, or the functionality of your app is more complex, and you have a bunch of nested calls or API calls, that would get really messy, right? Because then you have completion handlers inside of completion handlers, inside of if statements, inside of guard statements, and it's just a bunch of really complex logic, and things are much more likely to go wrong. So we can do all of that using async await with this simple line of code right here. We just have to add a couple keywords to let our compiler know how this is going to work. So first one being async. So async call in a function that does not support concurrency. So if we go here and just hit fix, then you guys will notice that something pops up at the top there. So this is indicating to our compiler that this is an asynchronous function. So then we get another error, but before we fix that one, because we are using this as an asynchronous function, we're going to go here and say await. So basically this await keyword just indicates that we are going to await a response from this URL session. So, and then it's going to be stored in this tuple here. And we don't, like I said, have to use a completion block, and our code is not going to go forward from this point until it gets a response back from this URL session, whether that is a successful response or an error. So we also have to mark this with a try statement. And basically what the try is saying is like, hey, I'm going to try to get you this data back, but there's no guarantee that I'm going to be able to do that because things can go wrong, right? You could be trying to retrieve data from a bad URL. You could be, your internet connection could get interrupted. All kinds of things could go wrong. So we have to mark this with a try keyword. Okay. And then because we're trying something and there's a potential error that could happen, we need to also make this function throwable. So here, we're going to say that, hey, this can throw an error, right? So now this is all good to go. So let's just do a quick recap on that. So we said that this function is going to be asynchronous. And because it's asynchronous, we're going to be awaiting a response from this URL session here. When we get a response back, it's going to store it inside of this tuple as the data that we get back with a potential URL response. Or we're always going to get a response back, but that response code could be okay, it could be an error, whatever it may be. And Then we have to make sure that this function can throw an error, and we have to make sure that we mark it with a try as well, because things might go wrong. So we have a bunch of like keywords that we have to implement, but this is way, way cleaner already than our URL session code down here. So let's just keep going with our execution, guys. I want to check our response code just to make sure we're good to go before we continue on, right? So we can say guard response as HTTP URL response dot status code equals 200 else return. So we are going to handle our error in a little bit, guys. I want to just get through the process of getting all our data back and displaying it on our user interface. So we're just going to leave this with return for now. So this just makes sure that our response status code is 200. The reason we do this, guys, is because if it's not, that indicates that we have some sort of network or server error, and we want to indicate that to the user or know that ourselves as developers. So now that we have that, let's go ahead and see if we can decode the data that we get back. So we're going to say guard let coins equal try JSON decoder dot decode, and then you're going to use this option type from. It's going to be an array of coin.self from that data, else return. And here, if this fails, we would throw some sort of invalid data error, which, like I said, we will do later. And let's go ahead and see if we can just print out our coins, guys, or we can just say print coins. So let's see. How are we going to call this function now? Right? So you might think that you could just hop up to the initialization method and you could say fetch coins async, but it's not that simple, right? And that's because this is an asynchronous function. And in order to do that, we would have to mark this guy up at the top with async. And that you might think that that's fine, but then, you know, you have to make it throwable as well. And then when you initialize your view model, you have to initialize it with an await, and that happens back in the view, and it just gets really messy. So basically, guys, what we're going to do is we're going to write another function here called load data. And we are going to wrap this in a task. So go ahead and say task. And you guys see it's a unit of asynchronous work. And you can even specify a priority here to tell your CPU how important this task is to complete. So some might be low priority, some might be high priority. We can just go ahead and make this like medium. And go ahead and tab over and hit enter on that block. And then we are going to say await fetch coins async. Awesome. So you guys notice that this function call does have to be marked with the await keyword, and that's because it is an asynchronous process. So let's see. I think we also have to say try, guys. And then we are going to go here, and in the initialization block, we're going to say load data. And you notice, because now that this is wrapped inside of a task, that we don't have to mark it with async or anything. This task takes care of that asynchronous process for us. So guys, let's go ahead and run our code now. And we should get back a big giant print statement with all of our coins. So let's just go ahead and keep an eye on our console. And you guys notice that that's exactly what we get. We're getting back all the data for 50 coins because that's how much we're telling our API to give us back. You guys here see page equals 50 up at the top. So that's looking really good, right? We see Ethereum here, we see Bitcoin, all that stuff. So you guys, let's go ahead and talk about how much better this is than the URL session stuff, right? So we noticed that we don't have to print our coins anymore, but how much cleaner this code is than all of the stuff we had to do down here with this URL session, right? So we don't have a completion block. Our code looks synchronous, basically, right? It's going line by line, which is absolutely incredible. It's super neat. It's super efficient. It's super clean. And we don't have to do any of this nasty stuff. So this is why async await has been, is pretty awesome. And it's not just that, right? Like I talked about before, the stuff with URL session can get really messy. It's not just cleaner code. It's actually more efficient and safer code as well. And that's because we're basically giving all of the responsibility for how this code is fetched to our system. And that is used with this await keyword. So this await guy basically makes it so that this URL session guy is what's known as suspendable. So it can suspend this task as needed, and we can specify priorities for it as well. It doesn't block our main thread. We don't have to work with any nasty nested completion blocks that can cause retain cycles and a million different other things, right? This is just way better, way more professional code in terms of how you're going to use your networking layer in your projects here. So really love this, guys. Let's go ahead and see if we can now actually get our coins displayed here and what we have to do that. So we're going to just go ahead and say self.coins equals coins. And let's run our project again. And you guys are going to notice that this works, but we're going to get a warning. So you guys are going to notice it says publishing changes from background threads is not allowed. Make sure to publish from the main thread. So basically, for those of you who are unfamiliar with threading, API calls or processes happen on background threads. We don't want that stuff to block our main thread. The main thread is what is in charge of rendering and displaying our user interface. So you could imagine that if we had some ongoing API call while the user is interacting with the interface, it could make it really laggy, or it could even block the user interface, right? Which is really nasty. So that's why this stuff happens asynchronously on a background thread. So the issue that we face is we're trying to publish data, right? So this guy is a published property, and it's going to send that information over to our view, which has to happen on the main thread. And that's why you see this dispatch queue.main.async guy right here. Anytime you utilize a URL session, you have to use this to get your updates back on the main thread. Well, luckily for us, SwiftUI has something called a main actor. And once we do this and run our code again, we're going to notice that that error completely goes away. And that's basically just another way of getting your code back onto the main thread, or the updates that your code needs to perform back onto the main thread. I'm not going to do a super deep dive into actors, guys, but basically an actor is just something that SwiftUI has implemented, or Swift has implemented really. It's not unique to SwiftUI, that makes your code safer when interacting with APIs. Or basically, it just makes it so that anytime multiple things are trying to update or modify some sort of data object like this coins array, it makes it so that that is a safe process, and you don't ever have to worry about multiple things trying to update something at once and raise conditions and all of that stuff. So that's what actors are used for. And this main actor just gets us back onto the main thread. So you notice that now we don't have to use this nasty dispatch queue.main.async guy. We can just declare this to run on the main actor or the main thread, and it takes care of that stuff for us. So that is pretty much going to wrap it up for our async await code, guys. In the rest of this video, we're going to go over how to implement some custom error handling, some pagination, and some refreshing to really polish off this app and make our networking a lot more professional than when we started. So next up, we're going to be going over how to handle our error, guys. So this is important for a couple different reasons. One, it's important for us as developers to know what went wrong and where. So our custom error handling is going to help us out a lot when we have to debug things and when things go wrong. It's also important for the user experience. So whenever a user is using our app and something goes wrong, you're supposed to tell them that something went wrong and what exactly went wrong, so that they don't start to get frustrated and never want to use your app again. So really quickly, let's go ahead up to the top and create another published property here. And it's going to be called error, and it's going to be optional because it may or may not exist. And if you guys remember, in the starter project, we got this coin error enumeration that's going to help us handle a bunch of different errors in a custom way, right? We could have an invalid URL, server error, invalid data, or an unknown error. And then we're going to have the ability to implement like a custom error description to show to the user. So if we go back to the content view model now, let's go back down to our fetch coins async function and go over how we're going to start throwing errors and see how clean this is going to be. So if we have this invalid URL guy, we can literally just go here and say throw coin error dot invalid URL. And you'll notice, guys, that you no longer have to say return here. You see code after throw will never be executed. So it does basically the same thing that return does, except it throws an error, which makes our lives easier. So we're sort of killing two birds with one stone there. And we can move this all into one line of code to make it even more concise. So now let's check out this guard statement with our response. So if we get an invalid response, we're going to throw a coin error.server error, right? So we can see here how we're utilizing that enum to throw different errors in different situations. And then here, if we fail to decode, we could say throw coin error.invalid data, right? Because we failed our decode. So that looks really, really good, right? So now, in order for this to actually work, guys, we have to wrap this in what's known as a do catch block. So we're going to cut all of this code here, and we're going to say do catch. And we're going to paste all that code back in the do block. And this catch block is what's going to execute if that error actually happens. So then all we need to do here is say self.error equals error, right? Because if we throw an error, then this catch block will execute and we'll get access to that. So that's pretty cool, right? It reduces a lot of the boilerplate code that we have to use when we work with these URL sessions. So for example, if I wanted to throw an error here, I would have to, I don't have the ability to throw anything here, right? I would have to say self.error equals coin error.invalid, server error. And then I also have to return. So it's a little more annoying to handle the error in our URL session code, right? And it all has to also be inside of a completion block, which is also more annoying. So this is way, way, way cleaner and way more efficient than what we see down there with the URL session. So let's go over how we can actually display our error to the user now. So basically, guys, this error is a published property. So we're going to add a receiver in our content view to receive this error. And if it does, we're going to like indicate to our UI that, hey, we need to show the user some sort of alert message. So let's go back to content view, and we're going to add this .onReceive method, and it's going to be viewModel.$error. So whenever that error gets published, and just hit enter here, error in, it's going to execute this onReceive block. So we're going to introduce another property up at the top, state private var show alert equals false. And then we are just going to go back to this onReceive block and say if error is not equal to nil, then we're going to say show alert.toggle. Cool. And then we just need to create our alert, guys. So we're going to say .alert and then use this one for is presented with content. So right here down at the bottom. So this is presented, guys, is going to determine if the alert shows or not, and then the content will be whatever we put inside there. So we're going to say $show alert and then tab over and hit enter on that guy. Delete that, and we're going to say alert with the title and message. Okay, so this guy is going to be a text component, and it's going to say error, and then the message is going to be another text component that says viewModel.error.localized description. So let's go ahead and hit enter there. Just clean this up a bit and indent our code. And let's just go ahead and hit Command B to make sure everything builds. Okay, so let's just give this a default value because it's optional. Hit Command B again. Our build succeeds. Now let's go back and just create some havoc here. And we're going to just make the URL invalid. Okay, so just go ahead and like delete a letter from your URL, guys, and let's go ahead and run the code and see if it gives us back some sort of error message. Perfect. So it's saying the data is invalid, and that makes sense, right? Because we're still getting like a response back from this URL, even though it's bad. But this goes to show us that we have successfully like published our error and that we've triggered one of our custom error messages, and it's showing that to the user saying, okay. And then guys, if we go back here and say, put the O back in CoinGecko and run this again, it's going to load all of our data successfully. So this is looking really, really nice and polished, guys. This is the difference between an amateur level coder and a professional coder, someone that handles their error in a professional way and makes sure they take all those extra steps in order to, make your life easier as a developer in the future. An ounce of prevention is worth a pound of cure, I always like to say, right? Doing a little bit more work early on will save you a lot of trouble down the line. So That's looking really good. Now let's go over how to implement refreshability. So this one is super, super easy, right, guys? Pagination and refreshing is all we have left for this video, and it's just going to take less than 5 minutes. So we can go back to our content view, and because we're using a list here, we can say .refreshable. And when we want to refresh our code, we can call a function in our view model. So let's go back to our view model, and we're going to implement another function here called handle refresh. And I'm just going to say coins.removeAll. And then we're going to say view model, or sorry, we're going to say load data. So you do have to remove all the coins, guys, because if you refreshed it and didn't remove all the existing coins, it would just stack them on top of each other. So we don't want that, right? So let's go back here and just say view model dot handle refresh. Let's run our code again. And let's see what we get back. So you guys will notice that I can now pull this list down to refresh it, right? Which is really, really awesome. That's just another extremely important feature to have when you're implementing any sort of networking layer. You want to give the user the ability to refresh the data and get back a fresh batch of data. So next up is pagination, guys, which is also going to be super simple, right? So pagination does have the predicate that, or is predicated on the ability for your API to implement pagination, right? So lucky for us, this CoinGecko API gives us the ability to paginate our data. So what I want us to do is actually just go ahead and say private. We're going to create two properties here. We're going to say page limit equals 20 and private var page equals 0. So you guys will notice here in this big nasty URL string, we have some parameters in here, right? So this is fetching 50 coins. You guys will notice if I change this to 5 and run my code, that I'm only going to get back 5 coins, right? So here we're going to replace this guy with our page limit. So you guys will notice that I can inject values into this URL string, which is pretty cool, right? So now you'll notice that I have 20 coins. So I could adjust this page limit as needed, and it will take effect with how many coins I fetch at a time. The next property we're going to be looking at is this page guy. But before we look at that and actually get our data back from the URL, from the API and paginate it, I want us to go over how we're going to implement it in our application. So we need to go back to our content view, and on this coin row view, guys, we basically need to be able to detect if we're at the last coin, right? So basically, if I scroll to the bottom of this list, I want to say, hey, I've reached the bottom, fetch me more data, right? So that's what pagination does. For those of you who don't know, it allows you to fetch your data in pages or blocks. So that, imagine if we had 1,000 cryptocurrency coins, we don't want to fetch all of that data at once, right? We just want to fetch little chunks at a time and only fetch other, more data if the user wants to see it. So this is another huge pro tip for any sort of networking code that you're going to write in any of your applications. You want to paginate your data. So in order to do this in SwiftUI, we're going to go here and say .onAppear, and we're going to say if coin equals viewModel.coins.last, and then we can just add a print statement, say print debug paginate here. Okay, so our coin is not equatable. So basically, guys, all we got to do is say coin.id, last.id. Basically, just want to see if the last coin in the list is equal to the last coin in our data array in our view model. So you guys will notice that, keep an eye on the console. I scroll to the bottom, it says paginate here, right? Paginate here, paginate here. So now we just need to call a function. So it's as simple as this, guys. We can just say viewModel.loadData. So this is our load data function. We just need to modify this a tad in order to support pagination. So let's go back to our content view model, and we can just, this will work right now. It's just not going to work the way we want it to. So let me show you guys what this is going to look like now. So, actually doesn't work. Okay, let's see if we can figure this out. So what we're going to want to do is say self.coins.append contents of coins. So every time it fetches new coins, it's just going to add it to the list, right? So let's run this now and see if that works. Okay, check that out, guys. So you notice that it fetched a new batch of coins, but it fetched the exact same first 20 coins that we have. So you see Bitcoin here, and then if you scroll down, you'll see Bitcoin there again, and all of those coins, right? And if you keep scrolling, it's just going to be that same list repeated over and over again. And this is because we need to increment our page. So first off, let's inject that page value into our URL string. So we're going to say that's our page number. And then down in this fetch coins async guy, we're in our do block just going to say page plus equals 1. And let's go ahead and run this, guys. So now every time we call this, it's going to increment our page. And then in this API call, it's going to get us the next page of data. So I'm going to go down, and you guys will notice that once I get to 20, it starts 21, 22, 23, 24. And you guys, if you pay attention to the scroll bar, you will see that all this data is not being fetched at once. It's being fetched when we get to the bottom of the list. So as we get closer to 40, you guys are going to notice that that scroll bar gets smaller, right? Like it just happened right there. That's it fetching our new batch of data. And you guys see it's so seamless, right? There's no lag, there's no clunkiness in our UI, and everything is working beautifully here. So this is looking really good. We just have one more problem that we need to solve. I want you guys to go up and refresh your data, right? So you guys will notice that it starts at the next batch, right? It starts at 61 now, and we don't have like our original set of coins. And that's because in this handle refresh function, we need to reset the page to 0. Okay, so you just go here and you say page equals 0. So basically this was happening, guys, because our view model still had the page stored at whatever the last iteration was, 2, 3, 4, 5. So then when we refresh the data, if page is equal to 4, it's going to start giving you the coins that start at 80 in the market cap rank. So if we run this now, our app should be completely polished off and looking super, super fire. All right, let's see. I'm going to go down, scroll, scroll, scroll. Super, super fast, super seamless. And then go back up to the top, refresh. And you guys will notice that look how much bigger the scroll bar is, right? When I refreshed it, it only gave me back those first 20 coins. Or you could make it say whatever the heck you want there. Right, so that's going to wrap it up for this video, guys. Just to do a quick recap, if you want to stick around, we implemented this async await functionality, which was way cleaner and way safer and way more efficient than this old school URL session stuff, right? And then we also went over how to paginate our data and how to implement error handling. And we saw how much easier that was with our async await functionality because we have the ability to throw an error here and just wrap it in a do catch block. So although we did have to use 2 functions and sort of wrap this in a task, it is overall way cleaner than this URL session code. We don't have to use this .resume functionality. We don't have to use dispatch_queue.main.async. Handling the error is way easier. And the code in our content view is super, super clean, right? We can refresh our code, and this is what we need to do to handle our error. And then we are also paginating our data right here. So that is how you network like a mother flippin' pro, guys. So I hope you guys enjoyed this video. Make sure you like this video and subscribe to the channel if you want to see more content like this. And don't forget to check out my website at stephancodes.com. Where I have a bunch of professional courses. And if you guys want access to the source code here, just go ahead and become a member. And any one of these memberships will give you access to all of the YouTube courses. You guys can just go ahead and check those out and check out the other YouTube courses on the site as well. But thanks so much for watching, guys. Hope you enjoyed this one. We'll see you in the next one. Peace out.